Hello, in this video let's discuss second question of today's contest. You are given a deck of cards represented by string array cards and each card displays two lowercase letters. You are also given letter X. You play a game with the following rules. Start with the 0 points. On each turn you must find two compatible cards from deck that contain X in any position. The letter X, not the character X. Remove the pair of cards and earn 1 point. The game ends when you can no longer find a pair of compatible cards. Return the maximum of points we can get if we play optimal. Two cards are compatible if the strings differ in exactly one position. And the conditions are the length is up to 1 and each card is of length only 2. So each card can have only 2 characters. And X is a simple lowercase letter from A to J. So we have this. We have to find the maximum points we can get if we try to remove the compatible cards that both contain letter X in any position. And what are compatible cards? They are simply the strings which differ in exactly one position. So firstly, regarding the strings, there can be three types of possibilities. The first one is both these XX. For example, if X is equal to C, then we can have strings of type CC. So this is one possibility. And then the first letter can be X and second cannot be X. So X and C, where C is not equal to X. So it can be from XA, XB or and so on, which is not XX, except XX, any other string with the first letter X and the second letter different. And similarly, other third type is some other character and X. And this should not be equal to X. It can be A to Z except the given character X. So these three are the different types of strings we can deal with. So let's see individually. So let's say we will store all the types in vectors. So no need a vector for XX type because XX are unique and we can just store the count. So int of XX is the number of strings of both same character which is also equal to X also. Like it should be XX. And let's store in vectors. Let's store two vectors where F is the strings that will have the first letter as X and the second is not X. If both are X, then that will be counted in XX. If only first character is X, then those will be added in F vector. And if the second is X, we will add an S vector. So let's say we got this both and we got X as 7 and let's say these two are F and X we got. Now let's assume the answer for, so let's pair all these. So we can pair any of these, right? We can pair XA, XC because two cards are compatible if they differ exactly one and also can contain X in any position. So these both have X, these both have X, and these both are different in only one position, A and C. So you can find two compatible cards that contain letter X in any position. So these both XA and XC can be selected, right? So these two can be selected and can be removed and so on. So after doing this, let's assume that the answer because of this is answer 1. And obviously some may be left because for example we have 100 X's, we have only X's and they are 100. So we cannot pair any of this. So obviously some will be left. So after dealing all with F, let's assume that answer 1 is the answer we got from this vector and A left are the strings or A left are the strings that are left after doing the operations. And similarly, the exactly same with second as well. We can get some answer and there can be some left also. So answer 2 is the answer for second vector and B left is the set of strings that are left. And XX is type C. So for now, let's assume that answer 1, answer 2 we got. Somehow we got these both. And now if we get these, then is the answer simple to find. So let's assume these three are left from first vector, and these two are left from second vector. So after these both, we have 7 count of XX, right? So can we form these both? These all the individual in F are not formed. So only then they will be a part of A left or they already will be in the part of answer 1. So if they are not, only then they will be in A left, right? So ultimately XC, these can be a part of A left. Why? Because they both are exactly same. So it is given that they should be compatible. So one character should be at least different, but they are exactly same. So these cannot be part of pairing. So XC can be a part of F. So similarly, DX can also be a part of S. So let's assume that these two are the vectors A left and B left after pairing all those. So we have these two, and also we have 7 as XX count. Can we pair any XX with other XX? No, because even then these two are exactly same. So we cannot pair these both because it should be at least one different character. So we have xx, count of xx, we have some f and some s. So can we observe one thing? So it is clear that in a left we cannot do anything, in b left we cannot do anything, in xx left we cannot do anything. So what is the only condition we can think of? The only thing we can think of is pairing xx with other. We cannot pair f and b also. Why? Let's say this is xc and this is dx, right? So obviously the second one here is x and the first one here is x. So then in this way these both will be exactly be different, both characters will be different. This will be not equal to x. If this is x, then it will be here. So if that is in f, the first one is x, the second one is non-x, and if it is in s, the first one is non-x and second one is s. So obviously these two cannot be compatible because both characters are different. So we cannot pair f internally, we cannot pair f internally, b internally, we cannot pair xx internally, we cannot pair f and b also. Then what is the only case left? We must pair xx with f and xx with b. So let's assume that a left size is 3, b left size is 2, xx is 100. So if this is the case, then what is the extra answer that we can get because of left one? It will be simplified. Why? Because we can simply pair these 3 plus 2 with any of these 5 and 95 xx will be left. So answer will be 5. And what if xx is equal to 1? If x is equal to 1 and a is equal to 3, b is equal to 2, the answer will be 1 because we can use only at most 1. So we will use 1. We can either 1 from this or 1 from this, but ultimately the answer will be only 1. So from this we got that we can get a beneficial answer from left vector also. And what will be the count? It will be simply minimum of xx and a plus b. If xx is more than a plus b, then we can use a plus b count of xx and we can pair them with a plus b. If xx is less than a plus b, we will use all the x's to pair x's ultimately. So minimum of this will be extra answer. So we got one thing. The only thing left is finding answer 1 and answer 2. If we found these, then answer is very simple. Answer 1 plus answer 2 plus minimum of xx comma a left plus b left. This is the only thing, right? So if we get answer 1 answer 2, we can get the answer in of 1. But how can we find answer 1 and answer 2? So it is very simple. So for now, let's assume that these are not strings, and for now let's assume these are numbers, right? So let's assume, and also if we observe one thing, it is ways to store in vector, right? Because ultimately we want the frequency of strings. So it will be very beneficial if we store in the map directly, so that we can get the strings and we can get the frequency also. So let's assume that we are storing in the map. So in the map, count of x is 3, count of px is 2, count of bx is 4. This is the first map. And similarly we can have second map also, where xa count is 2, xb count is 50, something like that. So the main thing is, the main problem statement now is, given some set of strings, if we try to find the answer for this, then we can get the answer for this, we can get answer for this also, right? So the only thing now left is, given some map of string and frequency, we have to find the number of answer, what is the answer possible. So if we can find this, we can find this, we can find this, and as we found both answer 1 and answer 2, then we can get this also. So the main thing is, we have to find what is the answer for this combination. So for now, let's assume instead of strings, let's assume we have numbers, right? So let's say we have count of 5 is 3. So 5 may be any string, whether that is bx or xa or anything, but it must be starting with x or ending with x. So let's assume that these are mapped to some numbers. So x is some kind of new number, bx is some kind of new number, and so on. So now, given some numbers with the frequency, we have to find the answer for this. If we find the answer for this, then we can do the whole solution, right? So let's check how can we find that. The main things are frequency, right? Because in a same frequency we cannot pair together. If two different frequencies are there, we can surely pair together. So the main thing is the frequency, but not the value we have. So we can store in a new vector the frequencies and then we can sort, because frequency is important, but it is not important which frequency is first or second. So we can sort this without any problem. And now after sorting, let's try to think which to be paired to get the better answer. So let's assume that the vector is 3, 4, 5, which is the frequency. So this is sorted, and now we have 3, 4, 5, right? So let's try to pair these 3 with 3 in the second one. So we paired all these 3. So the answer is 3 for now. And then what are the things left? 1 and 5 are left. So we can pair these two also. So we can get the pair as 1. So the answer is 4 for this case. All these 4 were left. All these 4 were unused. And now let's take other possibility. So let's take these 4 and let's take these 4. 4 in this and 4 in this. And now what will be? It will be 4. And then 1 from this, 1 from this. So we got a new pair. So this is 5. So we got a better answer. Why we switched the case? Because from the first example we got that we are wasting the higher frequency element. Why? Because we have 3, we have 4, we have 5. We paired these two and here 1 is left. And now we used 1 and 4 is left. So indirectly it is like we are wasting the higher frequency. So now we start from higher frequency and now what we have done? 3, 4, 5, right? So 5, the before one is 4. So we can pair 4 of highest one with the below one, before one. So we paired all these 4 with these 4. So 1 is left. So the answer is 4 till now. And then we took 1 and we took 1 from this. So 5. And we left 2 elements. We got 5 pairs. So in this both, we got the 5 which is optimal. So this is the final answer for this? No. So let's say this is again 3, 4, 5. And now these both can be paired. These both can be paired. And then we got 2 pairs. And other also can be paired. We got 3. 2 plus 1, we got 3. And then we can pair the first one and last one. We can pair first one and second one. And we can pair first one and last one. So we have 3, 4, 5. We can pair 3 of this. And we can pair 3 of this. So now the answer is 3. And what are the things left? Here 3, here 1 and here 2. And now we can pair this one and this one. So we got 4. And we can pair other 2 also. So we have 3, 4, 5, 8. So we can pair these 3 and these 3 first. So it will be 3 pairs. And we have 3 and we have 1 and we have 2. So let's pair these 2 now. So we'll get 2, 0, 2. So we got a 4. And we can pair these 2 with these 2. So we added 2. So the answer is 6. So 12, all these can be paired together. So the answer is 6, but even this is not the case. So why is this failed? And why is this correct? So this is because initially we thought that the answer is dependent on the highest frequency element. But as we are removing the elements, the frequency will change, right? So for example, let's take other one. So we have 3, 4, 5 again. And initially we are concerned about the highest frequency. Now, so we are removing the highest frequency. So this is 4 and we removed the highest second frequency also. This is 3. So we got answer as 1. Answer as 1 pair. And now let's take again this one. So initially 3, 4, 5. So after popping the 2 highest frequencies, even then this is the case. This is highest, this is the second highest. And so we got the answer as 1. And now let's remove. So let's remove 1 from this because both are 3 and 3 are equal. So we can take any of these. So let's assume the first one. And then we are removing this and then we are removing this. So the answer is 2. And now, even now we are concerned about highest one. But here, till now we are considering these 2. So we have considered 4 and this now. But now we are considering these 2. So it means that as we are popping the elements, the higher number may change. If A and B indexes are highest in the first operation, they may not be highest after Xth operation. Other indices may be highest. So we are thinking about dynamic frequency after removing the elements, but not too frequency highest from the initially. So what can we use here? We can use a heap to find the highest 2 frequency values so that we are concerned with those. So we are using heap and then we can pop those and we can get the maximum answer possible. So let's take the dry run. 3, 4, 5. So initially pop 2 highest one. So we got 3, 3, 4 and the answer is 1. So pop the next 2. Let's assume these 2. And now highest are these 2. So now you can understand. So for example, till now these 2 are the highest one. And now these 2 are the highest one. So Obviously we want a heap to get the highest values. We cannot get always these integers because here these two are not highest, so our greedy will fail. So obviously we have to select the highest frequency after operations. So we are using a heap, and now these two are the highest, so we'll pop these two, and the answer is 2, and so on. We'll get 2 to 2. We can remove any, let's assume these two are removing, and we are getting 1 1, and then remove these two, and we are getting 1 0 1, and then 0 0 0, which means that all are paired completely, and the answer is 6. So in this way we can maintain a heap, and initially we can push all the map frequencies into heap, and then we can start popping the highest two and removing those frequencies, and if they are more, like if they are not 0, then we can add again into queue, priority queue, and so on. But time complexity is unlog n because we are using a heap, and heap accessing the highest element is of log n. But this may give tail. Why? Because in the before we are trying to boil down the numbers, right? For example, the value is 1 in 9 minus 2. We are dividing this number until we are getting a number which cannot be filtered together. So indirectly the time complexity of this will be n into log of 1 in 9, right? So even this may go up to 1e8 or 1 or more than 5e7. So it is better to not use n log n. If we try to get an of n, then it is very good. If it is not, then we can try to submit this. So let's try to think whether we can get any better answer, any better complexity than of n log n. So in these cases, the first thing is max. So take very small size array and start thinking about different frequencies and so on. So let's take the size as 6. So the main thing is what? The main thing is the maximum frequency of an element. So for now, let's assume that maximum frequency is 1. If the maximum frequency is 1, what it means? Every element has a frequency 1. So that only then maximum frequency will be 1, right? So if it is the case, then what will be the answer? It will be 3. Because if the maximum frequency is 1, we can pair any two numbers, any two pairs. So the answer will be 3. And if the maximum is 2, so let's assume that we have 3 and 3, and we have 5, 6, 7, 11. So the size is 6, so the maximum frequency is 2. Then what we can pair? We can pair 3 with 5 and 3 with 6. So we can pair 3 with 5 and 3 with 6, and we can pair 7, 11. So even in this case we are able to make all operations. So even now it is 3. And for 3 also, for example, let's assume that 3 3 3 and 2 5 7. So even in this case we can remove the highest one with every other. So even now the answer is 3. Now let's take 4. So for example, we have 3 3 3 3 and 5 7. So now what are the maximum operations possible? We can make these two and we can make these two, but we cannot make these two pair because these both are same. So from this we got that the answer is 2. But for the frequency 1 2 3 the answer is 3. For frequency 4 it is 2. And for 5, so let's assume 3 3 3 3 3 and 5. So even now we can only make one pair because we cannot make any of these pair. So now the answer is 1. So for 5 answer is 1. And if the frequency is 6, the answer is 0 because all are same numbers, we cannot pair any of them. So if we very clearly observe, what will it say? It will say that up to n by 2 the answer is 3. Up to n by 2 we are able to make all the pairs, so the answer is n by 2 itself. But after 4 the answer is gradually reducing. So up to 3 it is 3, but after 3 it started reducing. So why it started reducing? So it is because, and other important thing is, from this we are able to observe that if the maximum frequency is as less as possible, we are able to get the best answer. Why? Because if the maximum frequency is 1, we are able to achieve 3. But if the maximum frequency is 6, we are able to gain nothing. The answer is 0. So from this the main thing is we have to reduce, like we can't reduce, but it is best if we have the maximum frequency as less as possible, so that we can pair as many as possible. So that is what, if it is best if the maximum frequency is as less as possible, so we will try to pair more. So if it is n by 2, so for size 6 and the maximum frequency is 3, so we got that how many numbers are equal to maximum frequency? that many number of other numbers also exist. So if the maximum frequency is 3, what it means? Let's assume 3 is the highest frequency with 3 frequency. So 333. And if this is the maximum frequency, any other frequency is less than 3. So it means that there can be 5 or 5 or 557 or anything, because the frequency can be less than or equal to 3. So in this case, all can be paired with higher frequency number. So if the frequency is less than or equal to the size of by 2, it means that we can pair every pair. So the answer will be n by 2. Because from this we are able to clearly observe that if the frequency is exactly less than or equal to n by 2, we can pair the highest frequency number with any other value, so that the answer will be n by 2. So for example, let's take odd frequency. For example, we have n is equal to 5. So for odd, there may be a different case. So if the frequency is 2, if the highest frequency is 2, if the highest frequency is 3. So if it is 2, what it means? So 3, 3 and 5, 7, 11. And now what will be the answer? It will be 2, which is n by 2. Because for 5 the answer is 2, so it means n by 2. But we are wasting 1. So indirectly it is that n by 2 only. So if the frequency of the maximum frequency is less than or equal to n by 2, it means that we are able to form all the pairs and the answer is n by 2. But as the frequency is going to be greater than n by 2, then the answer will be reducing. Why? Let's assume the size is 100. So let's assume the size is 100 and the maximum frequency is 80. So it means that all 80 elements are equal and rest 20 elements are different. Maybe different or they may be equal, but it will be not equal to this number. So, but now what can be observed? We can pair all these 20 with 20 of the maximum one, and these other 60 will be left because we cannot pair those. So now what will be answer? It will be 20 here. And what is 20? It is n minus the maximum frequency. So n minus maximum frequency will be our answer.